Well, welcome back to video 3. So we're here to do it again. This time I've got a slightly more complex example, and let me explain the aspects of this that make it slightly more complex first of all. Firstly, our domain is 2 periods. We've got 0 to 4 pi instead of 0 to 2 pi. Now, because this is in a form where b equals 1, so we don't actually have a horizontal dilation, I know there will be 2 solutions for every single 2 pi, every single period. So in this case, I'm actually expecting 4 solutions. That's the first thing. It's all really good to estimate your solutions ahead. The second thing is that this is not going to give me a nice number. It's not going to give me an exact value. I'm afraid that's cut. And I'll show you that as we move forward. What I'm actually going to do is also lead this towards the equation 3 sine of a half x equals 2. So I'm going to change the equation slightly, not the domain, nothing else, just that 3 sine of a half x equals 2. And I'm going to change it so that b isn't 1 anymore and show you how to solve an equation like that. But that'll be for a little bit later in the video, and I strongly urge you to hang around and watch that. Here we go. Let's do this equation now, though. Step 1, rearrange so that sine x is just equal to a number, 2/3. Step 2, solve sine inverse of that number on your calculator or using exact values, but this doesn't have a nice exact value, so I'm going to have to do it on my calculator. And so that will be shift sine of 2 divided by 3 in brackets there, and I get a value of 0.7297 radians. So that's my radians. Just check you don't get degrees. Remember, radians are going to be between 0 and 2 pi, which is about 6.3. If this was in degrees, it would be 41.81 degrees. Now that's too big. So the domain is given to me in radians. I should be answering fully in radians. And the biggest mistake people make is they write down a degrees answer now. And you have to make sure that you're checking and being considerate of that. So if your answer is too big, then you've probably done that. And you have to convert it to radians. So I'm just going to convert it back very quickly. 0.7297. I've used 4 decimal places because the question's not finished and I don't want to lose accuracy as I go. So x is equal to 0.297 radians. I'm now going to use my unit circle to determine the second solution. You'll see I'm not using a graph this time. Here's my unit circle. Because we're talking about a positive value again, so this is positive, I know I'm looking for when sine is positive. So my cast diagram tells me that sine is positive in the first and the second quadrants. So my first quadrant solution is here, and that's 0.7, I might just say 0.73 to save myself a bit of time on here. And my second solution is there, where this is 0.73. Now over here, this is pi. So my second solution is actually pi minus 0.73. Now I've actually kept the exact value on my calculator. So I'm not going to lose any accuracy even though I'm rounding on the page. So I'm doing pi minus answer. And that gives me a second solution of 2.4119 radians. So there's my 2 solutions. Now, this is where I break it down and start thinking about, well, what additional solutions do I have? I've got my 2 solutions. I've used my unit circle. The first one is called the reference solution, and the second solution is the one that comes from the reference solution in the other quadrant. So I have either x is equal to, and I'm going to put it out here. I'll show you why in a second. 7297, or x is equal to 2.4119. Now I get my subsequent solutions by just doing a full rotation, a full period if you're looking at the graph, away from my initial solutions. So if I do a full rotation around from 0.73 on a unit circle, by adding 2 pi, I get back to that same solution. So I'm actually going to add 2 pi to this, and I get this. 297 plus 2 times shift pi, and I get 7.0128. Sorry, 7.0129. And my next solution is if I add another 2 pi, 13.296. And I can get a previous solution by subtracting 2 pi as well. So in this case, I'm going to subtract 2 pi from the initial answer, and I get negative 5.553. And I can keep on going. I can get more and more solutions. I can do it the same with my initial answer, 2.4119. And that gives me 8.695. You notice it's about the same distance above the solution above it, which is what I'm expecting. Plus 2 times pi again gives me 14.978. Now you'll see I'm being a bit inconsistent with my choices of decimal points because I don't want to bore you to death, so I'm just trying to do this quickly. 871. But what I have to do now is just do a quick check of my domain. Here, 0 to 2 pi. No, my apologies, sorry. That's the first question. Here's my domain, 0 to 4 pi. And remember, we expected only 4 solutions. I've got 8 solutions written down. It turns out that 0 cuts these 2 solutions out, and 4 pi, which is about 12.7, cuts these 2 solutions out. And these are my solutions. They're my solutions from the first angle in the first quadrant. They're my solutions in the second quadrant. And I've got my 4 solutions, which is what I expected. Now, you will get better at this, and you won't need to determine these. You'll know when you've got your solutions, but in the meantime, if you need to determine some extras and then cut them out using your domain, that's perfectly fine. Now, I have suggested that I would change this question slightly, and I'll do an example 3, which would be 3 cos half x plus 2 . Sorry, 3 cos half x equals 2. And I'm going to solve this one now. So here's just a couple of tips and tricks for if your b value is not 1. We do everything exactly the same until the end, essentially. So we calculate cos of a half x equals 2/3. And we calculate a half x is equal to, and remember our first solution was 0.7297 radians. Now this is where some people would go, great, now I double it. As soon as you double it though, you mess up the question. You really want to find all your solutions for a half x, and once you've found all your solutions, well at least your second solution in the second quadrant, then you start to double it. So the tip here is that I would go across and I would say let y equal half x. I'd make a simple substitution, and I'll cross that out and I'll put a y in there. And I'll carry on the question. Y equals 0.7297. And from our unit circle, we also got y was equal to 2.4119. Now you have to be a bit careful with the domain now, and this is an additional step. So remember our domain was x exists in 0 to 4 pi. Well, I'm going to update my domain because I want to work out half x. I want to calculate when is half x. And that'll be between 0 and 2 pi. I've just divided my domain, each aspect of my domain, by a half. It's like an equation. And that means that I want my y to be between 0 and 2 pi. I want to know when is my y between 0 and 2 pi. And if I go back to the initial question here, here are the other solutions. I've got no other solutions between 0 and 2 pi, do I? So therefore, my 2 solutions are y is equal to 0.7297 or 2.4119, and that means a half x is equal to 0.7297 or 2.4119, and now is when I can apply, I've found all my solutions in the domain, so now is when I do my last step, which is to multiply everything by 2 and I get therefore x is equal to 0. That's not even right, is it? 0.7297 times 2. I was going to do it in my head, but that's only going to end in disaster. 4594, or 2.4119 times 2 equals 4.8238. And they're both my solutions. And that's that question done. So you're going to come across questions where b doesn't equal 1. When you come across those questions, solve it with a substitution here, like we did at this point, and find all your solutions for y or theta or whatever your substitution is within your varied domain. So remember, we varied our domain there. And then do your little transformation back at the end, which we did there, and that will give you a full set of solutions. So there we have it. That is pretty much 3 videos on how to solve trig equations. That's all you need to know. Thanks for listening, and all the best.